So today we're going to be talking about parabolas, but we're going to be taking a look at some different parts of parabolas that perhaps you haven't explored yet, either in Algebra 1, Algebra 2, or even in geometry. So we know that a parabola is a U-shaped type of curve, alright? And so what you've probably seen before is something like this equation. We have ax squared plus bx plus c. We definitely see that a lot when we're factoring, right? We have a trinomial where we can factor those types of quadratics. Quadratics, remember, are parabolas, alright? But now we're going to take a look at some new parts of the parabola, alright? So in a parabola, we have this U shape, and there are infinitely many points along that curve, alright? And so there are some important parts. The point right here, we call this the vertex, alright? We have also something called the focus, alright? So let's take a look at the definition here. So we have a parabola is the set of all the points, so all the xy points that are equidistant, so that they are the same distance from the directrix, alright, that's new. So that's a line right here. This is kind of like an imaginary line, but this line right here is called the directrix. And there's a point which is called the focus. And so for this parabola, the focus is right here and the directrix is right here. Depending on what parabola you have, those two things will change location. Alright, now the midpoint between the focus and the directrix. So notice that we have the focus here, the directrix here, exactly halfway between those two things we have the vertex. Alright, now what's really interesting about the focus and the directrix is that if you were to connect a line from the focus to any point on the parabola, and then you were to connect that same point on the parabola to the directrix, those two line segments are exactly the same distance. They are equidistant. Same thing with the second point that they have here. If I were to measure from the focus to this xy coordinate and measure that distance, and then if I took that point to the directrix and measure that distance, they are equidistant. Okay, so obviously when you have a parabola, you're not going to see the directrix. This is something that you can find, but keep in mind that those two things do exist, and we use those to be able to find every single point on the parabola. So those are kind of things that are working behind the scenes that we don't really talk about a lot, but they're really interesting properties of the parabola. So let's talk about the equation of a parabola. So I'm going to be showing you some examples, but I want to talk about these properties and the equation and things like that first. So I would encourage you guys to definitely pause whenever you need, and then take some notes and write down anything that's new to you. Okay, so we've been talking about standard form of equations, right? We talked about the standard form equation for circles yesterday. So now we're going to take a look at what it looks like for a parabola. So remember that we're no longer using y equals ax squared plus bx plus c, right? This one up here, right? That's not the standard form, although that is another way to write a parabola. That's what we've normally seen. So let's take a look at the standard form of the equation, alright? So depending on the direction that the parabola is pointing, we have two different versions of the formula, alright? So you can see down here, I'll focus on this a little bit later, but if your parabola is pointing up or opening down, we're using this form of the general equation. X minus h squared equals 4p y minus k. Alright, and the only thing that we have to make sure of is that p is never equal to 0. Right now, if your parabola is opening to the right or to the left, which you can't really see right here, then you're going to use this second version of the standard form equation, which is y minus k squared equals 4p x minus h. Okay, so p is the distance between the focus and the vertex. Okay, the actual distance, not the coordinate of the focus. All right. If your equation, if or rather if your parabola has a vertex at the origin 0, 0, then you have these really simplified versions of both these equations, right? Because both of our HKs would be 0 and 0, and we'd be able to simplify that a lot, okay? So depending on the opening of your parabola, you will, like I said, use different versions of the equations. Alright, so let me move this over a little bit so you can see that better. But anytime we have an opening that's up or down, we want the x quantity to be squared. Okay? And anytime we have an opening right or left, we want the y quantity to be squared. So keep that in mind for some of the examples that we're going to do in a bit.